So now let us see the different characteristic of the op-amp because of which it is being so versatile and it is used in the different applications. Before going to see the application, let us see the equivalent circuit of op-amp. So this is the equivalent circuit of op-amp. So here Ri is input impedance, likewise Ri is input impedance and R0 represents the output impedance of the op-amp and the output voltage of the op-amp will be the open loop gain A multiplied by the difference between input signals V1 and V2. Okay, so this is a op-amp equivalent circuit. Now, this is a ideal op-amp circuit. Okay, now let us discuss the ideal characteristics of an op-amp. First one is infinite input impedance. It is denoted as R in. The input impedance is infinite in an ideal op-amp. This means that no current can flow into an ideal op-amp. Output impedance is denoted as R0. In an ideal op-amp, output impedance is 0. This means that the output voltage remains the same irrespective of the value of the load connected. This means whenever we are applying output load to the op-amp, the output voltage directly come across the load. Next, infinite voltage gain denoted as AOL. The voltage gain, it is also known as differential open loop gain, is infinite in an ideal op-amp. Then zero offset voltage. In an ideal op-amp, offset voltage is 0. So the presence of the small output voltage even when both the inputs are 0 is called offset voltage. This means that output is 0 if the input is 0. Next, infinite bandwidth. The range of frequencies over which the amplifier performance is satisfactory is called its bandwidth. The bandwidth of an ideal op-amp is infinite. Then infinite CMRR. The ratio of differential gain to common mode gain is called common mode rejection ratio and it is denoted as CMRR. In an ideal op-amp, CMRR is infinite. Next, infinite slew rate. Slew rate is the maximum rate of change of output voltage with time. So in an ideal op-amp, slew rate is infinite. So expression is S is equal to dV0 by dt, that is maximum rate of change of output voltage with time. So this means that changes in the output voltage occur simultaneously with the changes in the input voltage. That means how fast op-amp is able to respond to the output voltage. Next, no effect of temperature. The characteristic of an ideal op-amp do not change with the changes in temperature. Next, the last characteristic is zero PSRR, that is power supply rejection ratio. It is defined as the ratio of the change in input offset voltage due to the change in supply voltage producing it, keeping other power supply voltage constant. So PSRR is 0 in an ideal op-amp. So these are the characteristic of an ideal